That was literally the last word you said, was the word Firewire. That's all I remember. Okay, so we were talking about serial versus parallel is the punchline. So kind of having the discussion about the different types of hard drives. So the last couple of classes we've been talking about a lot of different things, and we've been talking about patterns of how file systems can work when you're having to layer file systems on top of file systems on top of file systems. So realistically, each hard drive has a file system on it. Then you have a file system which governs connecting multiple hard drives together, maybe in one of these storage area network boxes. Then you have a file system that's going to govern a bunch of storage area network boxes hooked together. And then you might have a file system that manages having a whole bunch of data arrays hooked together, maybe even over long distances, microwaves, and you might have offshore stuff, things like that. So punchline is that at every single level, a file system kind of meets the same requirements, but it accomplishes its task differently. Kind of make sense? Now, I think last time we were also talking about this idea of hard drives being like a array, where how big is each thing? We talked about them that each bucket of the array is called a block on hard drives, as opposed to a frame in memory. Okay, so we're talking about the different ways that data can be transferred, serial versus parallel, and this allows us to segue into drivers. What is a driver? Based on your current knowledge, what would you say a driver is?
Software for hardware.
Software for hardware? Okay, isn't that an operating system?
Specific software? Yeah, it's like specific. Like you have a driver for your Wi-Fi card, you have a driver for your graphics controller for your graphics card.
Okay, I agree. But what distinguishes, I don't disagree with you. That is what a driver is in terms of examples of drivers. But what's the difference between a driver and an operating system? Because we already said an operating system acts as the middleman between a human being and the hardware, where the hardware in that case is the computer, the whole computer, right? So what is a driver then? If that's what an operating system is, what is a driver? So let's draw a picture, like pictures. Plus, I've heard that Dane's a big fan of my artwork. I just made it up. Don't be a jerk. Where'd you hear that?
Who told you?
He's been collecting screen captures. These are gonna be worth big money someday.
Yeah, I have them around my room. A little shrine.
That would be so creepy. Every single, like, he has all these different random pictures of me, but every single one is just the back of my head. It's this crazy, weird, freaky fetish. Okay, so we have our operating system. We have our computer. Then we have our user. So that would be our high-level diagram of an operating system, right? Sits between the user and the computer. What's a computer? Okay. When you say hardware, okay, you said it's hardware. What kind of hardware? What kind of hardware makes up a computer?
Like memory, like that stuff.
What's it all?
Let's list it.
RAM,
Oh,
board.
well, I can only type so fast. Here, we'll do it this way. RAM, motherboard, CPU, hard drive,
Power supply.
okay?
Cables.
Gotta have a fan in there.
What about peripherals? Did I spell that right? Doesn't look like it. There we go. So, a subset of what a computer's made, what makes up a computer, because we could even go, what's a motherboard? You start talking about, individual circuits and stuff like that. So each one of these has their own details, but let's just say that this list is a reasonable approximation of what a computer is. Okay? So, RAM, we've talked about RAM in here. Processor, we've talked about that. We've talked about hard drives. What about power supplies? Does the operating system deal with your power supply? It doesn't control it. The power supply is a self-contained type thing.
What about your BIOS? You can change it.
Well, BIOS would be part of your motherboard, but we'll leave power supply on here. What are peripherals? When you hear peripheral, besides saying that's a hard word to spell, what are examples of peripherals? Peripheral would be extra crap that isn't in this list, right? What are some examples of these? Who?
CD or DVD or graphics card. Is that what you meant?
Sure. CD, DVD, graphics card. What else?
SD card reader.
SD reader.
The case.
The case really a peripheral? You probably could make some sort of weird, freaky argument that it is, but let's leave it off the list. What else? What about the NIC? Network interface card. All right, so let's leave it at that. Whoop, everybody relax. I need to center this on. Okay. So, those are peripherals. What's a driver?
It's a piece of software that goes in between the computer and the component.
What are components?
Everything you wrote down.
Both these lists are components?
Yeah.
Okay. No.
Or is it in between isn't that firmware for all the components of the top list, and then drivers are for the second one?
Well, hold on. That's another fun word. Firmware. What is firmware?
Doesn't it change the software that's on the RAM itself, or on the card itself, I guess?
I'm gonna give you a brief definition of firmware for right now, then we'll put it in my picture in a second. Software for hardware that lives on the hardware. Actually, let's say lives/runs on the hardware. And I'll capitalize on because it's important, not just because I always capitalize on. It's a policy. Did anybody watch Avengers last night? The show? Oh, no, not Avengers. Agents of S.H.I.E.L.D.
I did watch the Avengers last
Did you really? Told you.
Wow, that's really
Stalker. I was wondering if it was any good. I DVR'd it, but I watched Sleepy Hollow instead. That's a good show, Sleepy Hollow.
What is that, on Mondays or Tuesdays?
It must be Tuesdays, because that's when it showed up on my DVR.
I always thought it was Monday show.
My wife, I guess it's possible. I saw it on Tuesday. Maybe it is a Monday show. My wife is in charge of all recordings. I'm like a child. She just records all my crap, so I have it there available for me when I need to be entertained.
That's so much nice though when you like record shows, because instead of taking an hour, you can just cut it down to like 40 minutes.
43 minutes is what it is.
Get rid of all those stupid commercials.
I recommend, if you haven't seen it, I recommend Sleepy Hollow. Shockingly good show. Doesn't sound like it would be very cool, but it actually is quite fun, quite cool, and has biblical undertones. Christian worldview.
Point number 4.
Bank.
That's number 4.
Man, how many?
Been racking them up lately.
This class, or is it?
Just this class, because you banked one on Monday.
Seriously. Ugh. All right, so firmware is software for hardware. So let's get back to my lovely picture here. So what are drivers in this picture? Well, let's start with this. Is a driver software or is it hardware? Software. Okay. Operating system, software or hardware? Software. What's the difference between a driver and an operating system? You already told me that drivers are software that control hardware, right? What's an operating system? Isn't it software that controls hardware? What's the difference?
Drivers are added to the operating system.
Okay, drivers are an element of the operating system that sit between what?
Between the hardware and the operating system.
I think that's fair. I think it's fair for us to say that an operating system I'm going to draw this two different ways. So you could say that drivers actually sit between the operating system and the computer. But more realistically, why can't that center? More realistically, we might say that drivers sit. They're part of the operating system, where the operating system controls the computer, which controls all this hardware. But specifically, drivers control peripherals. Things that are not part of the common group of things that make up the basic computer. So, things that we would consider drivers otherwise are likely built into the operating system. Okay? And we kind of see that. Like if you buy a hard drive and you go onto your computer and you format that hard drive, the Mac lets you format that hard drive in like two different ways. You can either format it as a Macintosh format, or you can format it as FAT32 format for PC. It doesn't give you, if you look at Linux, there's probably 75 different file system options to choose from. Because that's that world, the world where people create new file systems and put them out there as test beds and all that crap. So the reality is that a driver is an add-on after the fact, because if we buy Microsoft Windows day one knows how to deal with certain file systems for hard drives. And there isn't like a driver we can install to teach it how to do other things. unless, well, to teach you how to do other things, given a common denominator hard drive. You can get a new external system that could that might be technically for storage, like a hard drive is for storage, that might have a driver associated with it that could talk in a different language. You know, that could talk with a different you know, a different file system, let's say, talk to a different file system, and that would come through this idea of drivers. So, what capability did drivers really give us?
Add things on.
Okay. So add things like, I mean, graphics cards are probably our best way of describing this. But let's go back before graphics cards. Well, we can talk about graphics cards, and let's keep it consistent. We'll talk about graphics cards. So let's go back before the advent of drivers. Did our computers have graphics cards? We hope so, because something had to go out in the monitor, right? Because what's a graphics card? A graphics card is the thing that turns whatever magic is happening inside the box and turns it into pretty pictures on the screen, right? That's what the graphics card does. So we had graphics cards before we had drivers. In the big scheme of things, I'm going to tell you drivers are a relatively new advent in operating systems, with an emphasis on relatively. It's kind of old hat now, but realistically, drivers did not become commonplace until like Windows 95. So we had many, many operating systems before that the idea of a driver did not exist. Well, maybe the idea existed, but the implementation of drivers did not exist. So how did it work? If we were running a machine with Windows 3.1, let's say, or a machine with DOS on it, DOS 1, that's probably even the better example. Let's go way back so there isn't like some sort of weird, freaky hybrid thing. So you're running a computer that's running DOS 1.0. How did graphics cards work?
Were they just built into DOS?
Something was built into DOS. How many different companies make graphics cards? Do you think probably back then there was at least more than a couple? Like you just said, two. Realistically, aren't there probably more than two companies that make graphics cards? There's this two that are famous, right? Kind of like Nike and Reebok, or Reebok seems to have lost its shine a little bit, right? Adidas is the new. Okay, so whatever. Nike and Adidas are your big names, but we know there's many other companies that make shoes, correct? Do you think there's probably a fairly similar modeling in graphics hardware? Makes sense. So back then, let's just say it was the same thing. And we could even say there was 10 companies that make graphics cards. Doesn't matter as long as there was just more than a couple, especially in the world where memory was at a premium. So we probably did not write functionality for 10 different graphics cards into DOS 1.0. We didn't have the A, hard drive space, or B, memory to deal with it, right? I mean, heck, we didn't have enough memory to deal with 4-digit dates, let alone trying to talk to 10 different kinds of video cards. How did we handle it? How would you handle it if you were solving that problem? So you're the guy who wrote DOS, and you need to support 10 different graphics cards. Yet you don't have the storage to deal with 10 different, whatever the predecessor to drivers is. So you have to work with one thing. How do you handle 10 different cards? Invent something. Yet, now it's a chicken or the egg problem. Yet, DOS computers, if you took 10 DOS computers and put a different one of those 10 graphics cards in each one of them, every single one of them would have displayed something to the screen. Right? So they didn't say, look, I know all of you make graphics cards and rely on your business to make money off selling graphics cards. But what we did is we put everybody's name in a hat. We pulled out one name, and that's the one we made work. Go ahead.
Were they actual graphics cards or were they built into the motherboard?
They were actual graphics cards. Even if they were built into the motherboard, it's still a graphics card. They've just taken the same stuff they put on the chip, they've just put it on board. So when you have motherboards that have built-in video, they're usually lower quality video. It's kind of for like all-in-one computers type thing, but it could still be a fairly powerful graphics card. It's just on board. So they take all that circuitry and put it on board. It's the same crap, the same internals. Or I guess from a graphics card perspective, it's externals.
I guess I would set a standard as to which it has to be capable of being compatible with the operating system, or else it can't be used.
Okay, so you're going to come up with the lowest common denominator between the 10 cards. What are the 5 things that all 10 of those cards must be able to do, have some sort of standard? And we will write to that standard. So we'll have one pseudo driver, whatever came before drivers, one piece of hard-coded proprietary software that knows how to talk that language, that generic list of things. What's the downside to that, from a hardware manufacturer perspective?
No competition.
Well, tell me, what do you mean by no?
Because it would take away your, I guess, drive to make the best of the best graphics card because it has to be downgraded immediately.
That's it. It didn't matter how great your graphics card capabilities were. The fact is, when you plugged it into a DOS machine, it was going to only have the features that met the minimal standard. It wouldn't be able to take advantage of the latest, greatest, coolest technology you've invented because the operating system didn't know how to control it. So what's a real world example of this? I mean, so let's, I'm trying to come up with there's tons of reasonable examples. I'm trying to come up with a great example. Well, here, let's just go this way. Well, this would be a good example. So cars. So how many of you, well, lots of people know how to drive cars, right? Okay, lots of people know how to drive cars. Now, if I put a car in front of you, could you drive it regardless of what kind of car it was? With some exceptions. You know, maybe some of you might not know how to drive stick. If you don't know how to drive stick, maybe that might be a problem. But if we put an automatic transmission car in front of any of you, would you be able to drive it? Probably, right? There might be, if the vehicle's too big, you might not, like parking it or backing up or something like that. But generally speaking, we know how to drive a car, right? How many different kinds of cars are out there?
A lot.
Okay, what makes cars different?
Horsepower.
Okay, well, you have some of it deals with the engine. Some of it deals with size, color. What about internal bells and whistles? I mean, isn't that a big part anymore of what drives price? I mean, because you can go to a Ford dealership and find 5 cars that are the same make, same model, same engine, but with different accessories, different peripherals added to it, and that's really what drives price. Leather seats versus cloth seats, the onboard navigation, onboard computer system versus, I have a radio, that kind of stuff, right? So if I put you inside of a car that had a zillion bells and whistles, but ones that you weren't necessarily familiar with, would you immediately know how to work with all of them? Or would you have to fall back to kind of your common denominator of I know how to drive a car, and I can, regardless of how fancy this car is on the inside, I could still drive it to work. You might not know what all the buttons do. I'm not saying you're not capable of teaching yourself what the buttons do, but in a pinch, you got into the car, turned on the ignition, and now you're going to go. There's going to be a large feature set of that car that you can't use because you're not familiar. You don't know of it. You don't know about it, right? But you can still drive it because there's that minimal list of things that a car must do. You got the ignition, you got the steering wheel, got the gas pedal, got the brakes, put it in drive, go, right? Outside of that, everything else is fluff. So that's how things used to work when it came to video cards. You had those 5 or 6 things that all video cards had to be able to do. And anything outside that was a waste of time. Wouldn't you agree? If, let's just say that we were all stupid and we couldn't learn about those new bells and whistles. You know, it was off limits. We only knew about those basic functionality, those 5 or 6 things a card knows how to do. Would it be worth the company's time to put all these extra bells and whistles into a car? Just to drive price? Because now they're selling a car at a higher price when the users can't take advantage of any of the extra bells and whistles. Does that make sense? So that's how it was back then. And that's essentially what Dane said. I mean, he said, why make a better video card if nobody can take advantage of it? Right? So that's where drivers come in. Now, let's say you had the better video card at the time they were writing the operating system. Could the operating system writers start writing for those better video cards? So we're talking about DOS 1.0 in our current example. But let's fast forward to a much more modern operating system, but still pre-driver operating system. Let's go Windows 3.1. Windows 3.1 did support different graphics cards. But those graphics cards had to be hard-coded into the language, hard-coded into the operating system. The operating system needed to know about them at the time the operating system was released. Does that make sense? So you could make a better graphics card then, but now you're on the, you have to beat the buzzer. You have to have that graphics card done and fully functional in time to get it to Microsoft for them to incorporate how to take full advantage of that graphics card within the release of their operating system. Now our modern day thought process is what? That, oh, well, if we miss the original release, we'll maybe make it into one of the first service patches or something like that, right? Did we have service patches with Windows 3.1? That's even newer than drivers. This idea of updating your software kind of in real time is very recent. That's a very recent advent. You had to wait till Windows 3.11 hit the shelves at Best Buy. Significantly more difficult than distributing software today. You had to wait for them to write the code, create the 15-disc floppy disk install program for the updated operating system, package it in a box, ship it to Best Buy, have Best Buy put it on the shelf with prices. Ultimately, you go in, bring it home, upgrade your machine, find out that one of the floppy disks was actually damaged, because you had 15 moving parts at this point. And, well, 15 individual disks, but each of those disks had their own moving parts. And how many of you have never actually touched a floppy disk?
Touched it, never used it.
So all of us have handled a floppy disk before? Okay. What about, so that's a 3.5. What about a 5 1/4 inch disk? Because man, those were way more dangerous. They didn't even have that little slide cover covering up the disk. It's just like, it's like a cassette tape where the top is just exposed. But you know how cassette tapes are not supposed to touch it, but it's like not that big a deal. Don't touch floppy disk. It would be bad. Plus they bent. I mean they were floppy. You know, the 3.5 inch discs. I mean, you could bend it because you're an adult, but I mean they were rigid things, right? No, floppy disks were not rigid. It was like a paper plate. It was that level of rigidity, like the cheap ones, cheap paper plates, not like the good Chinette ones. Who buys those? It's like if you're going the route of paper plates, I mean, who goes high-end paper plates?
If you're having a nice outdoor party, like a barbecue, right? I mean, you don't want to, but you don't want to use regular plates because you're having a lot of guests. You probably want to go with the higher end.
Well, you just paper. Two paper plates on top.
Well, I mean, like,
but I mean, you want to be a nice guest and give your guests.
Here's the equivalent example. Not that I have to tell you, but I'm a ridiculously freak show coffee drinker. So you always, would have never known. So now at my house, I have like my nice like travel mugs that I might grab, but then what ends up happening is I leave them in my car, and then the coffee ends up rotting in there, and I take it home, and then my wife, I'm at the mercy of how long it takes her to clean them, because I'm not doing it because it's not my job. Anyways, so truth is, I buy these styrofoam things in bulk because I keep them at our office too for the guys to drink coffee. We have a Keurig there and stuff. So anyways, you know, if you go into a grocery store or something and you look at like the coffee cup aisle, I mean, some of those like $4 for like 10 cups, something like that. And they're like the nicer cups with the nice lids and that kind of stuff. Now I like nicer lids than this, but you can get the cheapo version of the Starbucks lids. I bought 1,000 cups and 1,000 lids for like $50. 1,000 of these. And I mean, there's nothing wrong with this. It's probably better. Because you don't need one of those exterior things so you don't burn the crap out of your hands.
Bad for the environment.
It's not my problem. Are the other ones necessarily better? Because like the other ones, I think have styrofoam in them too.
I'm just taking this environmental science class, and they're all a little crazy about styrofoam. So,
Like McDonald's has really nice coffee cups, and those are styrofoam, but on the outside they look kind of nice. So I think the styrofoam is like the best insulation, but then they make them look fancier on the outside or something. Who in their right mind would buy 10 cups for $5 when they can get 1,000 for 50?
You could use the same cup over and over.
I do. If any of you go and look at my car when you pass it, you will see I have a collection of cups in my front seat. I rotate them due to, you know, what was the last liquid in that cup and was there creamer? I have a whole system. At any point in time, I need to be prepared to leave my vehicle with a cup that I can go and refill with coffee. Always be prepared. I always keep a swimsuit in the back, too. What does that have to do with it? You never know when you're going to be in a place that has a pool. And not everybody is going to like my appreciation of skinny dipping. So sometimes you got to put a suit on. I'm just saying. What was I talking about? Oh, what happened? So we had to race the clock if you're one of these graphics card guys. Because there was a point in time there where companies were starting to make better and better and better hardware. But we're having to play this game with the operating systems designers to make sure that the hardware was supported in their operating system. Or there was going to be support in the next version of their operating system. Now, with service packs, the operating system can support new file systems and things like that. Now, from our perspective as the software users, we don't necessarily appreciate how difficult some of the software drivers that they're building into the operating system may be. You know, when they add a new feature to this, it's, oh, now I can do that. The reality is that was probably an 8-month project for a team of 10 or something like that behind the scenes. But from a user perspective, it's like, oh, well, I don't have one of those tape backup off-site SAN storage things, so I don't need to worry about it. But it was probably a lot of real work hours put into that. So anyways, we came up with this idea of software drivers. How do software drivers work? When you go out to Best Buy and you buy the latest, greatest graphics card that came out months and months or years after the latest operating system, you expect to come home and take full advantage of that guy, right? Okay, so how do you think that works? Taking this exact same pattern of going from lowest common denominator to, you know, because before we basically had to design everything for that lowest common denominator. How do you think the drivers work? Go back to our car example. No matter how many bells and whistles are in each car, is there some commonality? Like any of us could look at something that is a car and say, oh, that's a car. Do you ever come up on something and like, is that a car? I suppose if you're at one of these car shows where they're showing you, you know, this is what we will be building in 30 years, you might wonder, is that a car? But generally speaking, you're not combing the parking lot at Target wondering which are cars and which are not, correct? You recognize a car because a car looks like a car. What allows you to recognize a car? Well, most cars, you're looking for wheels, you know, some number of wheels. Usually it's 4, but you know, sometimes you have like the pickup trucks. They have the dualies in the back, right? But we're smart enough. We identify that as a car. What do we say that guy probably hold more weight without the tires exploding? You know, but that's one way we identify cars. We identify them by doors. See the steering wheel, windshields, you know, so we can keep going down the list, right? We can identify a car. But we already said that every one of those cars potentially has a different set of extra crap in it. We didn't use any of that to determine whether or not it was a car. Whether or not a car has air conditioning doesn't change the fact of whether it's a car. It just changes the fact of one of the bells and whistles the car may have. So how do you think drivers work? Who writes the driver to begin with? Generally speaking, there's actually a little caveat there with Apple.
The hardware company. Usually
the hardware companies. So when you buy your latest, greatest ATI or NVIDIA graphics card, you know, they used to come with a disk. Anymore, it probably pre-installs some built-in driver into the operating system that came with the latest service pack, and then you go out to the website for NVIDIA and download the latest, greatest, whatever, take full advantage of all the crap that's in NVIDIA's graphics card, right? So the NVIDIA or ATI wrote the software that talks the extra lingo that graphics card knows. But what about, but how does that driver ultimately work? Because at the end of the day, what does it have to do? At the end of the day, it has to talk to the operating system, right? Which says, put stuff out on the screen. Can the operating system know about all the crap that NVIDIA is going to invent 3 months from now? Does Windows 8 know what NVIDIA's cooking up? Do you think Windows 8 will still be the latest Windows operating system a year from now? Probably. They're usually on a 2 or 3 year release cycle. So pretty likely. So do we know what NVIDIA is going to come out with a year from now? No idea. Yet Windows 8 today can support what NVIDIA comes out with in a year. How? How would you pull that off?
Well, using the car model, basically have your operating system be able to recognize what a car is by just the basics, like the wheels and the windows, and then have when you get the driver, have that information tell you about all the bells and whistles get put into the operating system.
Okay, so you have to be able to. So if you are teaching somebody how to operate a car, and that's essentially the part that's built into the operating system, right? The operating system is going to take their built-in software, which is a car driver, a person, and we're going to say this is how you drive a car. But the generic car, right? So then the guy gets in the car, and immediately there's like a book sitting there. That's the software driver. And the book says all this extra crap that this car can do. Now, how is that extra crap defined? Like when you go and get a new, you go and test drive a car and get a new car or whatever that has all these extra bells and whistles in it. I mean, when it teaches you how to do different things, why is it that you're capable of doing them? For instance, let's say we have a car that has one of these touch screens and a bunch of like basically an operating system that's running on it that you can go into these different menus and that kind of stuff, right? And you read the manual. The manual says go into this menu, then this menu, then this menu, then hit this, and it works. Why are you able to do that? Well, it's a set of instructions, but those instructions are given to you in terms of skills you already possess, right? It didn't tell you to grow another arm. It didn't tell you to do something you didn't already know how to do. It told you how to solve the problems in terms of what you already brought to the table. Does that make sense? So software drivers, when a company's making a new graphics card and they're having to write the software driver to interact with that graphics card, all of those instructions for interacting with it have to be written in terms of the things that the operating system already knows how to do. Does that make sense? So the graphics card might be able to do 5,000 things. The operating system might know how to do 10 different things. Those 5,000 things each need to be accomplished in terms of those 10. Does that make sense? That's the mapping. That's how drivers actually function. So those people who are writing the software drivers, sometimes they have to come up with interesting ways to tell the operating system, send these signals, these 900 signals, out of, in a certain order out of the 10 things that you know how to do, and as a response to that special code that you just sent me, I will do this amazing magic trick that you have no idea about. Does that make sense? So that's how software drivers are written. Software drivers are written in terms of the simplicity the operating system has built into it, and in terms of the complexity that the new, improved, latest, greatest, awesome hardware has built into it. That make sense? Okay, so having said that, I'll put this up on Angel, but I want you to write a 40 to 50. Let's do a 1 to 2 page paper on the history of software drivers. When did they come into existence? What operating systems? What was the motivation for them? That kind of stuff. What was that gateway drug that got us from where we were then to where we are today?
Saves that in my paper.
Make sense? All right, I'll put it on Angel right now, but I will see you guys on Friday.
All right, Monday?
Well, I'll be here on Friday. And if you're not, we very well might have a quiz.